Good afternoon, guys. Welcome to my room. We'll go on with our Python lessons. So this time, this will be the fifth lessons, I think. Without wasting any time, we can start our Python lessons. In these lessons, we'll go on with module definition and its calling procedures and its usage. Where we left in our demo 109, I define some function. Within the block of this function, I apply print command just as high, and out of the block I define a variable and I assign it as some function. This is the recall, and I make it printed. So after we run the program, here that's what I would like to show you. This is printed as high, and as a result of this funny thing, I here recall some function but without doing anything. So the content must be none. So none is printed, displayed here. We can not recall functions like this. In another example, I here assign foo variable as a print, and there is a comparison here. If foo equals to none, so print 1, else print 2. Here I would like to show you a possible notation here. This is of course valid as long as you want it to be executed in one line. Okay, and let's see the result of this snippet. Okay, the first condition is met. I mean, foo actually has nothing. Okay, and 1 is printed. In our other example, there are some examples with other data structures in Python. Dictionaries is one of them. Actually, in Python there are other data structures such as sets, lists, tuples, and dictionaries. Here we go on with dictionaries section for the time being, and my ages variable includes a dictionary. Dave 24, possibly his age, Mary 42, and John 58. So I use print ages, and this is the key. Okay, and print ages, this is another key. This is key part, this is the data part. So let's make it run to see the result. Okay, ages belongs ages of Dave 24, and in other line ages of Mary 42 is printed like this. Here I just want to indicate a key error here. This is on purpose. My dictionary called as primary is like this, and there are three members, 3 items: red, green, and blue, as red, green, and blue. And there are some definitions. This is the color components, I think. And just outside of the dictionary, I would like to make it printed primary dictionary as red. Okay, this is the member, and on purposely I try to print a yellow. Yellow is not a member of this dictionary, so what's gonna be happen? Okay, yellow, 9, primary key error. It gave a key error, right? In case if the member that you are tangling with is not a member of the dictionary, it gives key error. So you have to be careful about that. And these are the notation for dictionary. Other examples. This is bad dictionary. I assign it 1, 2, 3 semicolon 1, 2, 3. This is not a proper notation. In fact, as far as we know, members should be separated by semicolon, and each member that stands for key must correspond to another one. So this is a fake. This is not a proper dictionary construction. So there is another type error, unhashable type list. This list notation cannot be accepted as a key. Okay, this is a good one. First of all, here I intended to show that values corresponding to a specific key may be changed. Okay. This is the changing procedure. Here I declare a squares dictionary. These are the members, and this is the key. This is the value, corresponding value. This is the key. This is the corresponding value. And once again, corresponding value errors. And this is another key, and this is another value corresponding to that key. So I would like to change some members, some contents of this dictionary. So I say 8 in index 8 will be added, will be placed, and index 3 would be 9 instead of giving such error. So after that, let's print it, our squares dictionary. Okay, just as you see, 3 with error is corrected. Okay, and still this key and the corresponding value exist, and an extra 64 data is appended as key 8, right? Okay. So after we create any dictionary, just we can modify, we can change some of the keys and its keys content, and we also append another key with corresponding data. So here is another example for prime numbers, primes. Sorry, this is just as a dictionary name, not prime numbers. There is no relation with prime numbers. So actually it includes prime numbers, but this is not the case. This is not the point that I want to focus on. Here in one command I would like to print the dictionary primes with prime index 4. That means 7 would be expected as printed, right? Let's see it. Sorry, this one, 17. Just I made a mistake with my thumb. Okay, as you see, when I wanted to print 0, 1, 2, 3, index 4. Index 4. Okay, here I created another dictionary including 3 members, key values 1, 2, 3, and corresponding data. It's written form 1, 2, 3 as like this. And here I would like to show you blah blah in the blah blah structure. Just I can say that. Print 1 in numbers, okay, and print 3 in numbers, and print 4 not in numbers. Okay, just what is expected by printing this? It's a logical result. In fact, this is true. Okay, true will be printed, and this is not true. This is false because 3 is a value, not a key, and 4 as a key, not in nums. This is logically true. True, false, true. Let's make it run. Just as we expected, true. This is false, and this is also true. Here there is a paraphrasing for the case. The key is considered not the value. Here the key is considered not the value. 3 is not the key, of course. Actually it is value, so it is nonsense to put it in iteration section. Okay, let's go with another snippet. In our new demo, I would like to introduce a get method here. Here I declared a dictionary with keys 1, this one, and the other member is the key this, and the values like this possible also. This is another key, and its corresponding value, somehow confusing, but this is correct. Another key, and its corresponding value true. And just focus on this. This comma is somehow necessary. This is our dictionary structure, right? So I would like to get it printed, the orange key. Okay, this is the key part, orange. What is expected? Orange corresponds to 2, 3, 4, right? So 2, 3, 4, a list of 2, 3, 4 will be brought, okay, and will be brought to be printed, of course. And in the next print command, get 7. That means 7 will be searched as long as it exists, but of course none will be found for that, because 7 is not in our dictionary structure. So pairs.get 1, 2, 3, 4, 5, and this is the key part, not in the dictionary. This is the data part. This is actually logically true, not in the dictionary. So just we make it run and see the results. Okay, after performing this first print command corresponding to orange key, the contents of this key will be printed as 2, 3, 4. And with the next print command that tries to get 7, the seventh key, so none, there is none, so none is printed, because we cannot see anything regarding to 7. And with the third print command that tries to get 1, 2, 3, 4, 5 as not in dictionary, not in dictionary, so this will be printed not in dictionary. This is paraphrasing. So let's go with another one, 118. Here I declare here dictionary called Fibonacci. Okay, so 1 corresponds to 1, the key, second key corresponds to 1, third key corresponds to 2, and 3, like this. Actually, just as a reminding reality, Fibonacci numbers are like this: 1, 1, 2, 3, 5, 8, 5 plus 8, 13 plus 8. The previous two numbers are added together to get the next number. Okay, 3 plus 2 equals to 5. This is a Fibonacci number. This is another Fibonacci number, like this. So what is asked from us? It's asked to get Fibonacci for key 0, 4, 0, and get 7, 5. So what's the result of this code? Just what is expected is, let's focus on this part. Okay, 4, 0 corresponds to 4, 0, 0, 1, 2, 3 corresponds to 3, in fact. Okay, 3, 0, 1, 2, 3, 3. And what stands for 7, 5? That means 4 plus 3, 2 plus 3, 3 plus 2. That stands for 5. So by manipulating, I here before it's printed, just try to paraphrase what's the mentality, what's the logic of this notation and this printing procedure. So 3 plus 2 equals to 5. So 3 plus 5 equals to 8. 8 will be printed, right? Just look here. 4 plus 0, 4 plus 0, 3. For 7, 5. Okay, 8 printed. What is the next one? Okay, let's go with tuples. Tuples are one of the data structures in Python. As a reminder, the others are sets, lists, and dictionaries. We have already seen some examples regarding dictionary, so I presume, I hope you have a familiarization, you're familiar with dictionaries by means of my examples given here and my paraphrasing. Okay, this is the tuples notation, right? Parentheses and members indicated as strings or other stuff. Its name called verse. I call it verse, and I would like to verse the first member, index 0, I mean, and I would like to change the content of the members with index 1 to cheese instead of x to cheese. And what's gonna be happen? This is the explanation for that. Just before reading this, just make it run and see the result. What's gonna happen? With index 0, our member is spam. Okay, spam is written here, printed here. And what happens next? Just I try to assign other things, some other thing to the member with index number 1. Okay, instead of x, I try to put cheese. So it gives an error, type error. Tuple sub object does not support item assignment. Others saying you cannot change the contents of tuple. That's the case. Tuple's element cannot be modified. Here, let's go on with lists. Lists also are one of data structures used in Python programming. In our tiny list is like this, contains two members, 1, 2. List notation will have parentheses, open parentheses and close parentheses, and comma as separation element. So I would like to print the contents of list. So before this printing, I would like to make a paraphrasing explanation. For example, before this list, print list contents, and after that I would like to, okay, let's go step by step. Okay, where it is, print list contents. Okay, after that, without leaving any space, 1 and 2 is printed as contents of this list. Okay, print list without leaving, without saying any other thing. Okay, this is enough. This is just good enough to print the contents of a list. And here I leave an empty line, okay. And dictionary, I here declare another data structure. A dictionary, this is the key part, this is the value part, this is the key part, this is the value part. Okay, two comma is used as a separator, and curly brackets are used as the limiters. This is the dictionary, formal dictionary format. And print dictionary contents, once again this is the explanation, and print dict. So the contents will be printed in sequential manner like this. So another empty line here, just to make it easier to see the difference. Tuple, I here sorry, an example for tuple. Tuples are not modifiable in content manner. Parentheses are used in tuple, and comma also as a separator. And I would like to get it printed the contents of TP tuple, and this will also an explanation. Print TP contents 1, 2. This is printed 1, 2 like this. And I here I assign my variable named my tuple as 1, 2, 3, right? And I say print my tuples content with index 0, I index 0, index 0. Okay, print my tuple 0. Okay, in this example, just I wanted to show you for tuples it is possible to use without parentheses. In case if you assign the contents of it to another variable, my tuple, okay? And but of course, if the concern is to print a specific index member, So you have to indicate it. And in index 0, what is there is our first member 1. So let's go with another code snippet here. In our demo, I here declare an empty tuple as TPL. So I try to print out the contents TPL. Let's see what's gonna happen this time. As it is expected, null is printed. Here null means nothing to be written, to be printed. This is a hint. Tuples are faster than lists, but they cannot be changed. This could be considered while tangling with tuples and lists. Here I would like to show you another specification, another feature of a tuple. Tuples can include heterogeneous members, such as this is a single number, this is a list, this is a tuple, of course, sorry, and this is another tuple. Tuples can be used as in nested manner, and it is allowed to be reached by using their index numbers. Of course, in more than one nested structures, you have to use more than one indexing numbers. This is naturally true. Here I would like to get it printed tuple the first member 0 with member first and member 2, sorry, index 0, index 1, index 3 corresponding to. What's gonna print it out? This one, right? So I would like to focus on the one with index 1. So I would like to print it the second 0, 1 index. So it's going to be printed like this here. Okay, and this is another variant. Here I want to print the second member of tuple with index 3. That means not this one, not this one. Okay, this is 0, 1, 2. This is the second index. So I would like to get it printed the third member. Okay, 0, 1, 2, 3. The letter D will be printed. Okay, this. And here I declare my string as this is my testing string. Of course, this is a string. So I would like to show this structure. Just I said, in a heterogeneous manner, string members of tuples can be different from in nature. So here I declare my strings 0, member 0, member 1, member 2, and member 3. Okay. Okay, actually this is our original string, and this is extra elements. Is it possible or not? So after such structure, I would like to get it printed as my my tuple, my new tuple. So as we expected, 1, 1, 2, 3, A, B, C, D, and this will be printed for the first 4 letters. 0, 1, 2, 3. 0, 1, 2, 3. This only this part, including these 4 letters, will be printed as members of tuples in nested manner. Okay. And let's go on with list slices. Here just I would like to show you that in list, even if they are short or long, we can manipulate some slicing operations, just selecting some specific parts of those lists, such as from the beginning till the end, or from this up to here, like this. And our list is named as squares. So I'd like to get it printed, the member, the index 2 up to 6. In this case, this number is included. Okay, this is not included. Okay, so 0, 1, 2, 0, 1, 2, 3. 9 is included, so 36 is not included, and one again, 3 is included, 8 is not included. So instead of so many talks, just let's make it run and see the result. Just as I said, 36 is not included, but starting from here with index 2. Okay, this is the result of the first printing command. And what about this one? The third is included. 8, index 8 is not included. The third is included. Okay, 8 is not included, so 64 is not included. And what about the third printing command? 0 and 1 is not included, starting with index 0, and 1 is not included. So only 0, the first member, will be printed such so as to be 0, right? And I just preferred to leave an empty line here by using this command. And after that, once again, let's go on with squares. So semicolon 7 means from the beginning up to 7 is gonna be printed. That means 0, 1, 2, 3, 4, 5, 6, 7. So up to 49 will be printed. Again, this is not included. And what about the next example? From starting the index 7 up to the end of the list. So what is that? 0, 1, 2, 3, 4, 5, 6, 7. So up to the end. 3 members will be printed. So there is an explanation here. A is included, B is not included. This is the notation. Please keep in mind the first key, first index is used. This is the limit. This is not used. The previous value will be used. Let's go with our next snippet. Here I declare a list once again, including it seems it's squares, I think, yes, and I named it as squares, and I want to make it printed semicolon 2 and 2 semicolon 8 semicolon 3. What are they for? Okay, here it's printed by increasing 2, or by spanning value is 2. Just I can say that 0 is selected, 1, 2, 4 selected, and 9 skipped, and 16 selected, 25 skipped, this selected, and this is selected. This notation just can be used for specific selections. Just you can arrange this just to skip how many elements will be selected, will be printed, like this. And with the help of this notation, okay, just this is the limits from 2 up to 8. That means 0, 1, 2, from 2 up to 8, 2, 4, 5, 6, 7, 8. 8 will not be printed, and go 3 steps, in 3 steps. That means accept it 4 and go 1, 2, 3, accept this, and okay, finish. Because when we count up to 3, 1, 2, 3, this is outside of the limit, so it's not gonna print it. Okay. And with our other printing command, squares, I use squares list 1 semicolon 4, 1 up to the end with 4 steps. Okay, step in 0, 1 with 4 steps. Just count 1, 2, 3, 4. Okay, 25 will be printed. 1, 2, 3, 4, 64. Sorry, 25. After 25, 1, 2, 3, 4, 61 will be printed. And this is another negative index notation. Just starting from 1. Will be printed like this. Okay, just you can see the result starting from this. Okay, that means printing started by counting -1, counting -1 with this notation, starting with the first index. Okay. Just I can place another example to make it much more clear here right away. Just prefer the third and -2. What's going to be printed? Just as you guess, 0, 1, 2, 3. Okay, 9 will be printed. And printing process will be continue up to what? -2, -1, -2. So this distance, this space will be printed. Okay. This stands for that you have to go back such steps. Okay. This is the starting index. Up to this time we have come to the end of these lessons. In fact, instead of making a long lessons, I preferred this time not so long one, so I want to stop recording right away. In our next lessons, we'll go on with data structures and functions. Up to our next lessons. Be in peace. Please do not forget to subscribe my channel, YouTube channel here. Thank you very much for your sparing time. Thank you very much for your watching me. Bye bye.